Okay, hey everyone. These week's videos are going to be on data visualization. And so now that we are starting to get the hang of wrangling data in R, we are now going to start visualizing, and that is particularly by using a package in the tidyverse called ggplot. And so the goals of today are to introduce the ggplot package and its syntax and use some examples of scatter plots and box plots, and Tyler will build on that in the next video. And just as a good check-in, so we have been, kind of checking in on your repositories as you push your notes and homework and things up to GitHub. But so it is always good to check, am I in my project, which you can see up in the top right-hand corner, or by asking your console, what is my working directory with the getwd function, and it should look something like, it'll give you an absolute file path, but somewhere on your desktop should be in our Davis folder and your in-class project. And if you look at your Git tab, ideally it's fresh and empty because you have already pushed your edits and notes and things from previous stuff. But if you are having issues with that, please do reach out. But all right, let's talk about ggplot. So first, we are going to load in the tidyverse. And a part of the tidyverse, it's not populating on my console because it's already loaded, but is the ggplot package. So we could also just read in ggplot, but there are some other functions in other packages that we like from tidyverse. And we are going to read _CSV, the data that we're working with, our portal data joined. But right off the bat, I'm going to filter out some of the NAs, in part just because it makes visualization a bit messy. Be careful with this, right? It's not good practice just to filter out your NAs if you're actually exploring the data, but for just the sake of learning how to visualize, it makes our lives a little easier. And because we're going to be plotting weight and hindfoot length, I am just going to filter those out. So I can pipe straight from read CSV into my filter, where, just as a reminder, I'm using conditions. This is saying I'm using filter because I want to take away some rows. And I do that by saying take away all those that are not NA in weight and all of those that are not NA in hindfoot length, the exclamation point being the not. So we have our surveys data. So first I want to talk about what the general format of ggplot syntax is. So I'm just going to drop it in here, where typically we open up a ggplot function, and that function has two main arguments, which are the data and the mapping functions. And then in that, so we have data equals data, so anything around carets is stuff we'll plug in. Then the mapping argument actually leads to another function, this aesthetics function, where we insert our mappings. We then use a plus sign, which is in ggplot syntax something pretty unique. It is very atypical. I mean, we've been using the pipe to sort of move through a sequence of functions up until this point. But in ggplot, the plus sign has this effect of layering different attributes onto a plot. And we'll walk through that a little bit, and how that plus sign is used. And then this geom function is the third essential piece. So there's a million more things you can put on a ggplot, but we're going to focus on these three for right now. And geoms are the shape of the data. So do you want a scatter plot? Do you want a box plot? Do you want a bar plot? Geoms are pretty endless. And so you'll pick one, and that will be sort of the foundation of your plots, and we'll learn to build from there. So let's build this piece by piece. So first, we want to start with kind of a blank canvas to show how ggplot works. So if you open up the ggplot function, you input your data argument, data equals surveys. And what happens is when you're on this line of code, your RStudio should automatically toggle over to the plots tab. If you have an issue where your plots are jumping out, that's okay, but there are ways to sort of fix that. But what this gives you is the base of your plot. You can tell it's starting to do something, but there's no real information on the plot yet because we haven't told it what information to take. We only have told it so far what data to take. So we first lay out what information we want to give the ggplot by using our aesthetics. So add aesthetics for kind of mapping coordinates is a way to think of it, but it also takes more than coordinate arguments. So we start with our ggplot data equals surveys, and then we can add a mapping equals, and we then as the side of this argument opens up a second function, this aesthetics function, the way RStudio is describing it for me now is aesthetic mappings describe how variables in the data, something, to I think maybe attached to visual properties of geoms. So generally, the most basic aesthetics you'll need are going to be an X and a Y. Now, every geom requires different aesthetics, and so you'll have to get used to over time which aesthetics are needed for which geom, but typically an X and a Y is a good place to start. And so this is just defining your axes. So in this case, we should probably back up a second and think about what kind of geoms we have in order to, before we want to define our axes. So we're going to talk through 3 geoms today, or I think I'm at least only going to get through 2, but all the geoms have a similar syntax, which is geom underscore. So if you start that, you can really see a whole list of geoms in the ggplot package. But geom underscore point is for scatter plots, and geom underscore box plot are for box plots, and then et cetera, et cetera. But in choosing your geom, it's important to think through what kind of variables do I want to plot, right? And this feels a bit basic, but it does take a little while to say, okay, it's good to kind of close your eyes, envision the figure that you want, and then work backwards. What are my axes? What kinds of data are on these axes? And so first, we're going to start with some geom points and use some of our continuous variables. And then we can step to using both continuous and categorical variables. So in this case, I want to plot something that's continuous by continuous. And so I'm going to choose the 2 continuous variables that we filtered the NAs out for, which are weight and hindfoot length. So I'm going to set X equals weight and Y equals hindfoot length. And again, in tidyverse language, I've already specified that the data is surveys. And so I do not need to call upon this column name with any kind of indexing method. I can just give it the name. So let's see how this works. All right, so now we've gone from our blank canvas, and note that you can use these arrows to kind of toggle back between plots. So we start with our blank canvas, then we've layered on aesthetics, weight as our x-axis, hindfoot length as our y-axis, but we haven't filled it with anything because we've given it the map, these aesthetic mappings, but we haven't given it the shape, which is the geom. And so we can add one more layer, right? Add layer for the geom. So here's our base. And now here's where we're going to use our plus sign. And then I typically space down after a plus sign, just like I often space down after a pipe for readability. You do not have to. So you can just do a plus sign and go straight to geom underscore point, open and close parentheses. So we'll start filling out arguments inside this geom, but as a baseline, you can just leave nothing inside that geom. And when we go to plot this, great, we get a scatter plot. So there are a lot of static things we could tweak here, but this is the basic idea: data, mappings, geom, you have a plot. As I was saying about the plus sign, you can put a space after the plus sign, and this code will run exactly the same. But you cannot press enter and then plus sign, I don't think. This will run you an error, and it actually tells you, did you accidentally put a plus on a new line? Tidyverse does not like that. Okay, so this is our base of plotting. Now, the cool thing about this plus sign and layering concept is that you can save bits and pieces of the plot as objects and then layer on from there. So you don't have to kind of keep repeating the same long text over and over. So for instance, if I call this base underscore plot, not point, plot, all right, getting there, and then assign it to an object, you'll now see in my environment, I have base underscore plot. It says it's a large GG, so it saves it as a ggplot, and I can run just this, and again, print the same plot. What's even cooler is I can use the plus sign to continue to layer pieces onto this. So I'm actually going to make my base plot without my geom, and then what we can do is layer geoms onto the point layer geoms onto the base plot and play with that from there. So my base plot is just my data and my mapping now, and I'm going to add a geom point, but here we can also play with sort of adding some plot elements. And we're just going to talk a little bit about transparency, color, and infill. So one of the first things you might have about this plot is like, well, this just looks like a big mass of dots. I can't really see the points. And so there are lots of different ways that you can tweak the aesthetics of your plot. And you can do these in a few places. We're going to put these arguments inside geom point, and these arguments are going to be the alpha argument, the color argument, and or the fill argument. So we can just play around with these. So if we add this argument inside geom point alpha equals, we'll experiment with it and see what we think it means. So alpha is a numeric value that is going to tell you a little bit about the transparency. And let's see, if we put in 0.5, okay, we start to see more see-through dots, kind of. So this gives us an idea of where points are aggregated. And I can never quite remember whether 0 is super transparent or not. Yeah, so 0 is super transparent. I think the default is an alpha 1, if this looks a lot like the plot that we had before. And you can always open that up. So yeah, we can make points more transparent to help with visibility. But we can also add on more attributes. So you can separate these by a comma, or you can give different examples. But let's say we also wanted to specify a color. So this will be the color argument. And I'm going to note that there's so much stuff to ggplot that no one really memorizes all of it. You'll kind of get a basic idea just through practice. And then there's a million Google resources for this. But I happen to know alpha, color, and fill are, for me, along with shape, are kind of the most common arguments that go inside geoms. So let's say I want to give this a color. Now, there are a set of colors that R knows. So for instance, if I say blue, R knows what blue as a character means. There are lists of these online. I think it knows what the color tomato is, for instance. But I don't think it knows all the colors. So let's see. So it doesn't know what mauve is, right? So it doesn't know all the colors. It knows some of the colors. But you can also give it a hex code. That's how many characters are hex codes? 6 or 8 values. So you can look up and pretty much find any color that you want. I think that this is just the black hex code, so not that useful. But you can give it a color. You can, instead of giving it a color, so you'll notice that the color argument fills in the dots with that color. But if you, well, actually outlines, this will be a fun game. If you instead use fill here, we actually have no impact. And so this differs between the different kinds of geoms you use, acts differently depending on geom. So we can walk through that in our next example. But here's some basic arguments that you might want to use. But what else we can do here is we can also color or use these different attributes based on the data itself, right? So not just red or blue, but what if I want species 1 to equal blue and species 2 to equal red, etc. And this is where plotting gets fun, but it does start kind of twisting your brain a little bit about what goes in which parts of this argument. So let's say we start with our base plot, and then we want to add on, a geom point. But instead of just saying color equals blue, we want colors to be the same as species ID. Our intuition might just say color equals maybe species ID, right? But what's happening here is R is looking in its list of colors and it says, I don't know what species ID is as a color. Well, does that mean, does it want it without quotation marks? It says species ID not found. You know, can it tell me what if I say colors equals survey species ID, unknown color name NL? And so there's something special that we need to do here that brings us back to that second layer of the ggplot that we learned, which is using our aesthetic mappings when we want to specify something about the plot that has to do with the data itself. And so when you want to do that, what you have to do is you can wrap things like color inside the aesthetics function. And so not only can we use that mapping argument inside the ggplot function, but we can also use this mapping function inside any geom and do our mapping equals aesthetics. And then here, if you put something inside aesthetics, that means you're calling on a point of the data by which to specify something about the plot, add that plot element, add that plot coordinate, etc. So now when we try this, it's not the best choice as far as visualization readability, but what we've done is R has picked a default color scheme and given each of our unique species IDs a color and has given us a legend and has mapped it on as such. So let's see. So this point, I think, is one of the hardest to get used to of when to put something inside aesthetics and not. So we'll sit with it, we'll practice it in class and move on. Because the last thing I want to talk about is the geom box plot. So now that we have the basic intuition about how ggplots work, right? ggplot data, mapping plus geom, maybe with some additional mappings, we can learn about different geoms. So let's give it a try. But now we want to learn about a geom box plot, which again, as I said, is a categorical bicontinuous. And so, because if you tried to do a box plot with two continuous data points, it just wouldn't really make any sense. So let's move on to that. Data equals surveys. And now our mapping equals aesthetics is going to be where X equals species ID. So now we have a categorical on the X-axis because we want, if we close our eyes and say, okay, we want a box plot that looks at the distribution of weight by species, then we could imagine the species ID on the X-axis where each of these unique species IDs has a little box plot. And then the box plot spans on the Y-axis the different weights, in this case, of the animals. So we've set those mappings, and now we want to say geom box plot. For now, we will leave this empty. I continue to spell species ID wrong. And look, I think this is more or less what we imagined. Now on our X-axis, this categorical variable has given us however many unique species IDs we have, and the Y-axis is a box plot showing the distribution of their weight. As I noted before, fill is one of those things that I think acts differently here. So if we fill tomato, I think this is going to fill all of our box plots with the tomato color, whereas if we use color equals tomato, it will outline all of our box plots in tomato. So just keeping in mind, there's kind of a subtle difference of those things here. And last, we can also layer multiple geoms on top of each other. So if you want to have a box plot, but also look at kind of a scatter plot spread of the data on top of or behind these box plots, if we add a plus geom underscore point, it's ugly for now, but what you get is actually all of the points representing our data that really would be better if we like laid them behind the box plot. But maybe this is something where we'd put a really low alpha. So these would kind of disappear potentially, although they're still pretty thick. And so what you'll start to realize the magic of these layers is that if you, the order in which you layer them will tell ggplot the order in which to stack them on top of one another. So now we have taken a ggplot, we've given it our mapping arguments, we've then said put points on with a high transparency, but then layer on a box plot that's the color of tomato. And now this is what this plot is telling us. So this is an introduction to only the tip of the iceberg for ggplot. Tyler will get into more geoms and some more nuance. And then next week we do a deeper dive into making these more visually appealing, frankly, in kind of all the different functionality of ggplot. So looking forward to talk about this in class.